Hey everyone, welcome back to the channel. Today we are going to tackle an interesting problem, 2 sum. This is problem number 1 and here is the problem statement. Given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to the target. Let me take an example. Suppose we have input array nums with elements 2, 7, 11, 15 and the target is 9. We need to find two numbers in this array that adds up to 9. So the output here is 0, 1 because the value at nums 0 is 2 and the value at nums 1 is 7, which adds up to 9. 2 plus 7, 9, which is our target. Also we need to return the indices of the numbers, so that's why 0, 1, and the output should be in the form of integer array. Also we cannot use the same element twice. Each number in the array should be used only once to achieve the target sum. So to explain this, let me take this example 3, 3 and the target is 6. So we need to find two numbers in the array that add up to 6. So now since each number in the array can only be used once, we cannot use the same element with 3 which is at index 0 twice to get the target sum. We will need to find two distinct numbers that add to 6. So the output here will be 0, 1 and not 0, 0. So now let me delve into the main approach. Here the objective is to identify two numbers in the given array that sum up to the target value. So to accomplish this, I will adopt a systematic iteration process where each element in the array is examined one by one, and for each element the algorithm searches for its complementary pair. So complementary pair basically another element in the array that when added to the current element equals the target value. And once such pair is found, the indices of the elements are returned as the solution to the problem. Let me start with a quick base case. If the input array is empty, then we return null. Here we are taking into account negative and positive values, so no check on that. So to implement this approach, I will utilize a double for loop. So this is the outer loop. It will execute until we have elements in the array and we will iterate each element one by one. This is the inner loop which we will set to I plus 1 because the inner loop iterates over the remaining elements after the current one set by the outer loop. It will iterate as long as array has elements. So within the next nested loop, I will check for an element which when added to the current element set by the outer loop equals target. And if such an element is found, we will return the indices of both the elements. And if at the end of the loop, here our loop ends, if we don't find such suitable complement pair, then we will just return null. Keep the code clean. Let us run. Accepted. Submit. Okay, so let us go over one example. Here we will take nums 2, 7, 11, 15 as the input array and target as 9 and go through this algorithm. So the outer loop starts with the first element of the array, which is 2, and the inner loop starts from the next position after I, which is 7, and here we check 2 plus 7 is equal to 9, which is our target, and it matches, so we return the indices of 2 and 7, which are 0 and 1. Suppose this wouldn't have been a match, then we would have gone with the second iteration, which is j would have incremented to the next position, that is 11, and we would have checked if 2 plus 11 is equal to 9, and the inner loop would have executed this check for all elements in the array with number 2. Then for the next, the outer loop would have set to 7, and inner loop would have checked all the elements starting from the next element after 7, which is 11, 15, and would have performed this check. So we would continue until the outer loop finishes iterating over all elements. In this example, the brute force approach successfully found 0 and 1, which correspond to the numbers 2 and 7 that add up to the target 9. But time complexity wise, this approach involves checking every possible pair of numbers, resulting in O of n square as the time complexity, where n is the number of elements in the array. So for larger arrays, this approach might not be efficient due to its quadratic time complexity. However, in terms of space complexity, this approach does not require any additional space besides the input array itself. So the time complexity here is quadratic time complexity O n square, and space complexity is O of 1. So in this previous approach, we have encountered nested for loops, and when we have this outer and inner loops iterating over all items in the given array, it often results in quadratic time complexity. So this might not pose a significant issue for small data sets, typically seen in the problem examples here, but the impact becomes pronounced as the size of the array grows to thousands, tens of thousands, or millions of objects. So although the operation performed on these numbers might be simple, such as addition and comparison to other number, the sheer volume of comparisons required, numbering in the hundreds, thousands, millions, or even billions, makes this approach insufficient. So despite the simplicity of the individual operation, the algorithm here overall suffers due to its O of n square time complexity. Let me think how I can eliminate this double for loop to improve the efficiency. So we can leverage map, which is collection of key value pairs. Specifically, I will utilize a hash map to store element of the array along with its index. So in the hash map, the element serves as the key and its corresponding index serves as the value. So HashMap provides constant time complexity O of 1 for key lookups, making it optimal choice for this problem. So now let me comment this approach and name it approach 1 using nested for loop. Now let me start with approach 2 using HashMap. Okay, so I begin by initializing an empty hash map to store each element of the array along with its index. So map integer the value is also integer as it's the index of the number. Here I will be using HashMap. Done with the initialization. Now let me add the elements and index in the hash map by iterating through the array. So here the key is the element and the value is the index. Now the next step is to identify the complementary pair. So for this we need to first get the complement of that number. So the complement of a number is what we obtain when we subtract it from the target value. For instance, if our target is 9 and we have number 2, so its complement would be 7, as subtracting 2 from 9 yields 7. So the complement of a number is what we seek to find to reach to the target. So let me iterate through the array again to get the complement for each element, and then I will check if the complementary value exists in the hash map. If it does, then we found pair of element whose sum equals the target value. Let me code it. So here I will take complement as the variable which is integer, and we will calculate the complement of current element where I is pointing at. I is pointing at index 0 here. Okay, now we need to find if the complement exists in the hash map. Map dot contains key and if it does, return true, then we have found a complement pair. And if it returns true, then we have found our complementary pair. So it return the indices of both the elements. How to get the indices of how to get the index of the complement number? By using map.get complement, which will give us the value for that key, and the value here is the index. So we need to add one more check here, which is map.get complement is not equal to I. So this is to ensure we don't pick the same number twice while finding pairs. We are adding this extra check. This makes sure that when we are looking for a complementary number in our map, we are not selecting the same number we are currently considering. It's like a safety net to avoid repeating the same number in our pairs, making our solution cleaner and more accurate. For example, here the target is 6 and the input array has 3 as the element. So if we are looking for complement of 3, we shouldn't accidentally select the same number 3 which is at index 0. It should select two distinct number. So it's for that. Let us run this and check. If at the end of the loop we don't find the suitable complementary pair, then we need to return null. I think it should be, yeah, it's submitted. So let us go over the time complexity and space complexity for this approach. So the time complexity here is O of n. As we iterate through the array once to store the element with its index in the hash map, and once to find the complementary pair. The space complexity here is O of n as we store the elements in the hash map. By adopting this optimal approach, we significantly improved the time complexity of our solution from O of n squared to O of n, and making it more suitable for larger input arrays. There is one more approach where instead of iterating through the array multiple times, as we have seen here, once for storing all the elements in the once for storing the numbers along with its index in the hash map, and again iterating through the array to find the complement pair. We can do it in one pass. So let me name this approach as approach 3. Here is modified approach which I am thinking. For this I will still use HashMap. So we need to initialize HashMap, and it will store the numbers along with its index, numbers as the key and index as the value. So here I will traverse the array as once, so using for loop. I will calculate the complementary value by subtracting the current element from the target value. So int complement equal to. So what we will do is we will check if the complementary value exists in the hash map. If it does, then we found a pair of element whose sums equals the target. And how to do that? If map dot contains key, the complement, then we return the index of that number. How to get that? By doing map dot get index of that complement and the index of the current element. Else we need to if that complementary value is not present in the hash map, then we need to add the current element along with its index in the hash map. If no valid pair is found at the end, then we simply return null. Oh, sorry. So now let us go over the time complexity and space complexity for this one. So during the array traversal, storing each element along with its index in the hash map ensures that we can efficiently look up the indices of the complementary elements in the hash map when needed. So this approach maintains optimal time complexity while ensuring the solution works effectively in one pass through the array. So time complexity here is O of n, as we iterate through the array once to store the element with its index in the hash map and to find the complement pair. And space complexity is O of n, as we store the elements in the hash map in the worst case scenario, n being the length of the array. Now let me talk about the next approach, where we are going to store the complement of the number as the key and value as the index of that number. The idea here is we will get rid of the nested for loop and traverse through the array once. Basically for this approach, I will still use HashMap as it provides a lookup in constant time. Basically, I will traverse through the array to find a pair of number that sum up to the target value. Let us take an example. For each number in an array here, I will calculate its complement by subtracting from the target value. Example, for number 2 here, its complement would be 9 minus 2, that is 7. And for number 7 here, its complement would be 9 minus 7, that is equal to 2, and so on. So the algorithm here is first traverse the array to check if the number already exists in the hash map. If the number is present in the hash map, then it is present as a complement in the map because we are storing complement of the number. That is, there was a number previously encountered in the array which needed this current number which we are basically traversing as the complement to add to the target. And if we found that, then we return the index of the current element and the index of the complement number from the map. If not, then we store the complement of the current number. So 9 minus 2, that is 7. So we stored 7 as the key in the map and an index of the current element as the value in the map, which is 0. So 7 and 0 will be stored. 7 as the key and 0 as the value. and it's for number 2. Okay, so because we are storing the complement of a number and not the number itself. And if at the end we don't find such complement pair, then we return none. Let me take an example to explain this. So this is the example. So the element here is the input array nums 2 with elements 2, 1, 4 and target value is 6. The output would be 1 and 1 comma 2. So first we iterate through the array. First element here is 2. We check if this number is present in the map. That is, was there any number previously encountered in the array which needed this current number 2 as the complement to add to the target? So it's not, our map is empty. You can see it here, our map is empty. If not, then we can calculate the complement of that number here. Our number is 2 and its complement would be 6 minus 2 equal 4. So we'll store the complement of 2, which is 4, and value will be the index of the current element, which is 2, and index is 0. Now let's proceed to the next element. We'll repeat the same steps again. We'll check number 1 is present in the map. That is, was there any number previously encountered in the array which needed this current number 1 here as the complement to add to the target? It's not the case. So we need to calculate complement of 1. 6 minus 1 equal 5. So we'll store complement of 1 as the key and value as the index of the element, which is 1. Index of element 1 is 1. Okay, and its complement is 5. We'll follow the same drill. Check if this number is present in the map, number 4. And yes, 4 is present in our map. You can see. Okay, so basically 4 was encountered before as a complement. That is, there was number previously encountered in the array which needed 4 as the complement to add to the target. So we found a pair. So we written the indices of the current element, which is 2, and output should be 0, 2. Okay, and index of the number which needed 4 as the complement, which we get from the map, 4, 0 is the index which needed 4 as the complement. Let me code this part and explain. Okay, so I will initialize map here. Is the complement of the number and value is the index of the number which we are looking at. So both are integer. Then I will traverse the array. So I will use for loop. Then we'll first check if this number exists in the map. So what we will do is we'll basically take the value. We will check if there is value for this number in the map. If not, then it will return null, right? So, and if there is value, then we would need complement index, right, to return. So we can use that itself. We don't have to do it twice. We'll check if complement index is not equal to null. And if that is true, then we found the pair. Will return an array with complement index as one we will get from the array, and index of the current element, this I. Okay, and if that is not true, then we have to store complement of that number. So we'll calculate complement. Okay, so nums I, and then we will subtract it from the target to get the complement, and then we will store the complement of this number in the map dot put complement as the key and value as the index of the current element, so that is I. And if at the end we don't find such pair, then we will return null. Accepted. So let me submit this. So regarding the time complexity and space complexity, time complexity for this is O of n, and as we are using HashMap here, so space complexity will be again O of n, because we have to store complement of all the elements if that pair is something like this, like we have to go till the end, so we have to store complement of all the elements in the hash map in the worst case. So O of n, we can see in this example as well, we need to go till the end. So yeah, thank you, that's all.